So there's this e-learning platform that causes everyone pain. But I'm here to convince you that it's so painfully bad that it's actually good.
Oh, such pleasure.
I didn't mean to cause you any pleasure, which causes me pain, which gives me pleasure.
In this video, we're going to learn how to use a tiny bit of computer science to finesse the most popular yet hated education app. When you visit a URL for a website, your browser sends a request to the server. This is called an HTTP request. For example, let's say you visit example.com/feet. The server then sends back the relevant data, which your browser displays as a web page. This is called an HTTP response. Using the same example, the server might send back images of feet. Canvas is no different. When you need to access a file like a homework assignment, your browser sends a request to the server. In order for the server to know which file you're looking for, it needs a unique identifier called an ID. This ID is usually a number, and it tells the server exactly which file you want. The server then sends back the file to display. Let's go through an example course for a calculus class. I'm currently in the syllabus section. Not every class would have this, as some professor may post a syllabus in the home page or in the assignments page. But in general, this trick will work for files posted anywhere in the course. Notice that there's an underlined link. This means that there's a URL for the actual file. We can right-click on it and click Copy Link Address. Now, if we paste the copied URL somewhere else, we can examine it a bit more closely. First, we can delete everything after the question mark. Next, notice how the file is uniquely identified by the number 8000. This means the file for the syllabus that we copied from earlier is at location 8000. A syllabus is typically posted at the beginning of a course. So let's look for a file that was posted later, like a homework assignment. If we scroll down, let's copy the link for homework 1. Let's examine this link. Just like before, we can remove everything after the question mark. You'll notice that homework 1 is at location 9000. Now we can come up with a rule. The bigger the number, the newer the file. On the flip side, this would imply that the smaller the number, the older the file. Most professors like to reuse their old courses. This is like a chef reheating leftovers from last week, but still charging you full price. So if you think your professor has been naughty,
you naughty, you teasing me, you naughty.
You can apply what you've learned so far. In our example, recall that the oldest file was the syllabus at location 8000. You've probably figured it out by now, but why not just subtract 1 from the file ID? If you get this message, don't worry, just try again, and keep trying until you get a file that works. If you're a lazy fuck like me, you can automate this process. Here's a very simple Python script to automate method 1. For file IDs from 7999 to -1, we will dynamically construct the URL for each specific file ID and store that result. Then, we will make an HTTP request to the stored URL if the HTTP response status code is 200, which means the request was successful. Then we will print that we found the URL. Let's say each request takes 0.5 seconds. Then this script will take roughly 8000 steps times 0.5 seconds, which equals 4000 seconds, or 1.1 hours. This is definitely faster than method 1, but not as fast as myself in the bedroom.
Yo, you wanna see some real
If we want to make this even faster, we can divide up the work from method 2. Let's say one computer, called worker 1, will explore the even numbers. Let's say another computer, called worker 2, will explore the odd numbers. Now they can work independently, and we can get roughly double the speed. But why stop at 2? You can extend this framework to as many workers as you want. The key is to make sure each worker jumps by the total number of workers. This guarantees that each worker will be checking a different file ID, regardless of how many workers you have.
Nice.
Now let's put it all together. But before we start, we need to give our code permission to act on our behalf. First, make sure you're logged into Canvas. Then, right-click Inspect and go into the Application tab. you'll see a section called Cookies with the Canvas URL. Copy the value of the canvas_session cookie. Now open a terminal. I'm here in my desktop.
Here in my garage, just bought this new Lamborghini here.
Type cd canvas-tool and hit enter. Now you're in the same directory as the code. I've linked the code in the description, but let me quickly show you how to run it. Type export canvas_session equals in all caps, paste the cookie you copied and hit enter. Make sure not to share this with anyone. Now we can run the script. Make sure Python 3 is installed on your device. Type Python3 canvas.py-URL and paste the URL of the oldest file. In our example, this was the syllabus. Then type --num workers to specify how fast you want it. I'm going to choose 32 workers since Canvas gets mad at anything larger. Last, type --num files to specify how many files you want to check. For this demo, I'm going to choose 1500, but in practice, you would choose 10,000 or 100,000. Finally, hit enter and watch the magic happen. The script will check all the files below 8,000 and notice the 404s in the beginning, which means no file was found. After a few seconds, we found all these files faster than finding my dad. Notice that we can check the outputs folder for a structured list of the results. This list contains all the file names and download links of my professor's old assignment solutions. I will not be doing homework this semester. If you thought running the Python code was too complicated, don't worry. I've also built a web version of this tool, which I will also link in the description. Just make sure you're logged into Canvas in a separate tab. The web version is a bit slower, but it works just as well. Thanks for watching, and let me know if you have any questions in the comments.